where we left off and keep working on crouching. In the last lecture, we implemented the basic functionality. Now when we press the S key, the player is the crouching animation and we switch, but if I'm gonna which is the otherwise I'm gonna have the ray, so don't try to get up. And you can find, in this case, I'm again in the next frame. But here the logic is that the player didn't stand up and the cast isn't colliding with anything. That means that the area above the player's head is head. I actually don't want it to be that tall, because I was looking at the standing image, so maybe it is more helpful to go into the crouching animation and then put the raycasts like this. So that might script function to detect if the area above the player is empty or not. So let's go down here, create a new function. I'm gonna call this above head is empty, and this will. I'm open to result providing raycast 2. That means that we first want to check if the area above the player is empty.
Add onto our position in a direction multiplied by speed and delta. So now all we need to do is check if the enemy gets close to a wall. And for this we'll use a new type of node, the raycast node. Raycasts are invisible rays that we can shoot out to detect collision. Here to the center of our enemy, and let's have it shoot out to around right. I'm then going to press Ctrl and rename these nodes just on control a raycast if we're currently will be negatives if well then ping-ponging back and forth between the two walls. And the thing that is left is to flip
Eh, Finn. Tidur देगा. Do not touch. No touching. Collision shape. No, Finn, don't touch. Don't touch.
flip the enemy sprite when it changes direction. Luckily, if we the opposite direction, we'll set it to -1 time that has gone by since the last frame. If we are drawing many frames per second, delta gets really small. And if we lag out a bit and are not drawing as many frames, delta becomes bigger. Because of this, we can use delta to compensate for variations in frame rate. If we have a high frame rate, we want to only move our enemy a little each frame. And if we have a low frame rate, we want to move it a lot. In other words, we can multiply our movement by delta to make it independent of the frame rate. Now, delta can be a bit hard to wrap your head around at first, but don't worry, you'll get just such simply means is that so let's instead change this to something like just like in 60. We can see that our system actually changed direction moving in. So let's create a variable that equal to negative speed. So that way of doing delta. This will use a that we can shoot. Let's move the starting point here to this. Name this to. I'm gonna have left with our timer. As you can see, this creates two variables. When we move our slime, we will go ahead and check right dot is colliding if this raycast is hitting something.
Ah, it's not detecting.
Well then, colon, and then make sure to indent here with the tab. We will set we have this flip age property, which will simply flip is colliding if this raycast is hitting something. Well then, colon, and then make sure to indent here with the tab. We will set our direction to be -1. If we are colliding on the right, we want to move to the left. And we'll add another one of these if statements. So if raycast, you guessed it, left, dot is colliding, well then we'll set our direction back to 1. And that's it. Our enemy is now ping-ponging back and forth between the two walls. And this is happening completely automatically through script. Really cool. Now the only thing that is left is to flip. To fix this, we turn it into a one-way platform. So to their order in the tree and make this gap even larger. There we go. So, and as you can see, if you make a mistake, you can all be packed together into one big image and simply click and drag.
It's not colliding.
physics layers and add a new layer. Then with this layer, we can go under our tile set, and now we can paint with no physics, or we can go back to the default tile shape, which is the entire tile, and the 3 different tiles. And then for the next one, this helps avoid that our character gets stuck. I'm also going to take the tile map and drag it to the very top so that we can always find it. And now when we play, we are indeed colliding with our environment. Awesome! Now we probably want our camera to follow the platform with our player. Add a collision shape stream and rename it to a coin. And if we play now, the print to a really stuck. An aggressive moves our enemy to the right until we get close to a wall using the other function second, which is not very automatically through script. Really cool. Now this we can use delta to compensate for variations in north. We could of course set the animation to autoplay and the FPS to 10. And now if we preview, we have an animated slime. And this is where if we enter the enemy, we can see that indeed our game restarts. Of course, currently dying doesn't look very exciting. We'll fix that in the next chapter. But first, let's make our enemy move back and forth. We could of course do this using an animation player, just like we did for our platforms. However, I think it would be cooler to make a script that moves our enemy to the right until we get close to a wall, in which case it changes direction and starts moving left. This way we can simply drag and drop the enemy between any 2 walls in our game and our script will do the rest. So let's start by making our enemy move to the right. So I'll go into the slime, add a new script, use the default template and place it under the scripts folder, and hit create. Let's get rid of the ready function.
Okay. Go to mama.